Our project consisted of 3 different tasks at a high level. Our first was to implement a basic Maple programming abstraction, not necessarily all of the bells and whistles that it contains, but at least a naive implementation. We also aimed to implement a Maple adapter in Open Daylight, so to leverage the code that Open Daylight already has to enable Maple. And finally, to also provide some sample algorithmic policies, which we're going to demonstrate later as well. So on the right-hand side of this slide, you can see that we've kind of shrunk the area that the user needs to be concerned about when trying to program flows. So they just need to specify the algorithmic policy. And then Maple is basically the controller that's going to compile the flow rules and pass them to some message layer, something like Open Daylight or Floodlight, which will then distribute those rules throughout the network using OpenFlow. In terms of the project to make a Maple adapter in Open Daylight, we first had to become familiar with a rather large source code repository, and we also had to become familiar with the tools that they use, such as Maven, which we used as a build environment. The first thing that we did was to add Maple as a bundle to the existing code base, so to make it interact with the code. And after that, we slowly added functionality for receiving and sending packets to switches, receiving port up and down and also link up and down notifications, so we had to add listeners for that information. And we also had to implement functionality for installing and deleting flow rules on switches. And these things weren't necessarily easily exposed to programmers in Open Daylight. So in some cases, it took us a while to do the right digging to find what we needed to do. But once we were able to get this functionality, then we could give it to the Maple part of our code, which could then do further processing and call upon this code as well when it needed to do things like send out packets or install flow rules. So it kind of defined a bidirectional interface. In order to do much of this work, we had to take advantage of the module-driven service abstraction layer in Open Daylight. And this is basically the layer that contains all of the low-level functionality that we need to leverage, such as the actual message passing abstractions and installing flow rules, things like that. So we had to tap into this MDSAL in order to get Maple to run. On the other side of our code, in the Maple code, we first defined boilerplate code for various types of packets and flows, such as classes to define matching for flow rules and actions for flow rules, different types of packets like ARP packets, Ethernet packets, etc. All of that was needed before we could do any kind of Maple rule generation. The first step of the actual Maple algorithm was then to observe how algorithmic policies examine packets to build traces. So this is observing things like when the high-level function f reads a field from the packet. Once we have that, we could use those traces to build trace trees, and then write functionality to actually compile those trace trees to flow rules. And as the network changes, or as the policies in the network change, we needed to augment the trace trees and update the flow rules as necessary. So as an overview, we have 2 different repositories. We have an ODL Maple repository, which contains the adapter, and we have a Maple core repository, which contains the core Maple functionality. So with this kind of setup, we could then go into other controller software, such as Floodlight, and implement something like a Floodlight Maple adapter and reuse the Maple core code in an environment like that.